Okay, good afternoon everyone. Okay, so for today we will continue our lecture, right? Organizing and graphing the quantitative or group data. Okay, so last week for tutorial 1 until 4 we already finished until the graphing and organizing the qualitative, and for today we will continue with the quantitative. Okay, same also we will focus on the frequency distribution table, okay, for the group data. All right, and then we have the graph. Okay, but then the graph is a bit different from the qualitative, because this one we have a histogram, frequency polygon. All right, we have a cumulative frequency polygon and so on. Okay, right. Okay, so frequency distribution here, okay, become more informative, more info, more calculation for this quantitative and group data. Okay, so the frequency distribution, okay, for a quantitative data lists all the classes, okay, lists all the classes and the number of value that belong to each of the class. Okay, all right, so data represented in the form of frequency distribution, okay, all right, are called the group data. Okay, so which means that under the quantitative data we might have a class boundary. Okay, we need to separate them into the class interval so that we can have a class boundary. Okay, we have the class width, all right, and then we also have the class midpoint. All right, so all the class boundary is given by the midpoint and so on. Okay, and then the class midpoint is a lower limits plus upper limit divided by 2. Okay, later we'll see the frequency distribution and then you become more understand on this topic. Okay, all right. So basically, okay, can see clearly, class? Okay, so basically for the frequency distribution table, the first one we need to have a class interval, and then the second one is a frequency. The first one is a class interval, and the second one is the class frequency. And then we can derive the class boundary, we can derive the class width, and then class midpoint. Basic is a class interval and also the class boundaries. Okay, so for this one, how to get the class boundary for the lower class boundary and for the upper class boundary. Okay. All right, so for here we have the class interval. Okay, we have the class interval and also we have the frequency. All right, so for the lower class boundary, it always on the left side. Okay, and then for the upper class boundary, it will always right. Okay, so this one is class interval, this one is a class boundary, this one is lower class boundary, this one is a upper class boundary. Okay, so for the lower, always minus 0.5. For the upper class boundary is always plus 0.5. Okay, all right, so always minus 0.5. This one is always plus 0.5. Okay, all right, so what else we have here? Lower class boundary and then upper class boundary, and then the class width, right? So the class width is start from the 5, 6, 7, 8. So that is why the class width is always 4. Okay, all right, so you see that different class interval, but then the similar or same class width, because that one need to be consistent, always 4. Okay, all right, and then we do have a class midpoint. Okay, so for the class midpoint, you can 5 plus 8 divided by 2. Okay, you can take from the class interval, or you may take the value from the class boundary. For example, you get 4.5 plus 8.5 divided by 2. Okay, class midpoint is always divided by 2 because this one is a general formula. Okay, you see that the class midpoint is always divided by 2. Okay, all right. Okay, so basically this is the frequency distribution table for the qualitative and group data. Okay, so we have class interval and then we also have the class frequency. From the class interval and class frequency, we can derive to the class midpoint, class boundary, okay, and then class width. Okay, all right. So we move to the next topic. Okay, characteristic for this one. Okay, this one is the same. This one also the same as previous. Okay, so we have the data. Okay, this is what we call as a quantitative data. Why this one is quantitative data? Numerical data, right? Okay, because this one is a marks. Okay, marks of a student. Previously, we see that the grade A, B, C, D. This one is a mark, so this one is a numerical. That is why it is represent the quantitative data. Okay, all right. So we have 40. We have 40 students in the statement. We have 40 students, and then we are supposed to have 40 observation. The data here should be 40. Okay, right. So what we need to do is same with the qualitative. We complete this one. Okay, so how to determine the number of class interval? Let's say if the question didn't give to you the class interval, so you need to create on your own the class interval. How to determine the class interval? The first one is by using this rule. Okay, by using this rule, k is equal to 1 plus 3.3 log n. What is n there? What is n? Number of observation. Okay, you can read from the slide. Okay, the number of observation or the number of sample that we have. All right. Okay, since n is equal to 40 according to this data, so the number of k is equal to 6.3. So approximately 6. All right. So for the class interval, we should have 6. Okay. Class interval 1, class interval 2, class interval 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6 class interval that we should have based on this rule. Okay. All right. Step 2. Determine the range. What is the range? The maximum observation minus with the minimum observation, which is the largest value minus the smallest value. Okay. From this data, the largest is 92 minus 37, you get 55. Okay. All right. So we can determine the class width. Okay, the class width is equal to range divided by the number of classes, which is 55 divided by 6. Okay, so you get 9. Okay, let's say here 9. So starting from 1 until 9 or 0 until 8. Let's say, okay, for example. Right. So for this one, okay, for this one, the test score will be 35 until 43, and so on. We create this one because the smallest is, what is the smallest? 37, right? But we start with the 35, okay, until 97. Okay, but then how many class interval there? 6 or 7? 6 or 7, right? 7, right? Okay. Why 7? Because this one, even though that the formula say the number of classes is 6, okay, we can add few more. Okay, we can add or minus 1, plus 1, or minus, plus or minus 1. Okay, maybe can be 7, maybe can be 5. Okay, right. Okay, so you get the class boundary, and then you start counting this one, 35. The first class interval is 35 until 43. So 35, 36, 37, 38, 39, 40, 41, 42, 43. So 9. The class width is equal to 9. Okay, all right. And then from the class interval, we can find the class boundary. Okay, and then we can find the class midpoint. Okay, all right. So class boundary and class midpoint is derived from these first two columns here. Okay, so the important one, the basic one, is a test score and the number of students. Please find it correctly. Okay. All right. So for the lower class boundary, always minus 0.5. For the upper class boundary, always plus 0.5. Okay. All right. So of course, in the test or in the final, so we didn't want to see any variation in terms of class interval. The question will provide to you. Okay. The class interval will be provided. Okay. We want to see the what we call a uniform answer. All right, okay, because if we decide to the student, so maybe there's a lot of answer. Okay, all right. So for this one, we can proceed. one same. Okay, this one also same, right? Class midpoint and so on. Okay, so the class frequency, okay, the class frequency can be expressed as a fraction, okay, decimal or percentage form of a total number of observation. Okay, this one. We also have the relative frequency for this one. Okay, you can write in terms of fraction, decimal, and also the percentage. Okay, we have 3. So what will be the relative frequency here? Number of frequency for each class of interval divided by the total number of, but why? The first column is 1/10. Why is 1/10? The first column there, fraction, the first column is 1/10. Because 4/40, okay, 4/40 and then you follow, right? Same as the categorical one, okay? So it depends. So if the question asks you relative frequency, okay, and then they didn't mention specifically, either this one should be in fraction, either this one should be in decimal or percentage, you can choose either one. No need. No, wait. The fraction should be in simplified form. Sorry, okay? The fractions should be in the simplified form. Okay, so to be safe, you just press your calculator. So the calculator provide you the simplest form. Okay? Alright, so this one is a cumulative frequency distribution. This one. This one. Okay, so for next one is a cumulative frequency. Why it is important for the cumulative frequency? Why midpoint is important? Midpoint is important because you want to draw the graph for the frequency polygon. Okay? But then for the cumulative frequency, you need to draw the graph ogive. Ogive or ogive? Ogive. Okay? Alright, ogive. Okay. So this one, what is the class boundary here? What is the cumulative frequency? Cumulative frequency. In bahasa we call it as a kekerapan longgokan. What is a cumulative frequency? Okay, it started with 0. Okay, so some of the reference book they didn't put the 0 there. It's okay. Alright, okay, so 0 plus 4 plus 9 and so on. Okay, plus 22 plus 31. Okay, how to get this? How to get this class? You see this one, okay? You see this formula is four, five, 30, 13, 9, 5, 3, 1. Okay, so for the cumulative frequency, you need to do like this. This one will be 4. Okay, 4 plus 5, you get 9. Plus 13, you get 22. Plus 9, 31. Plus 5, 36. Plus 3, 39. Plus 1, 40. Okay, you must get 40 at the end. Based on this. Based on this class, based on the number of student or frequency, you can find the cumulative frequency. Okay, so cumulative frequency is just like this. Okay, 0, 4, 9, 22, 31, 36. Okay, the last one you should get 40. The last row you should get 40. Okay, alright, but some of the reference book they didn't mention 0, so it's okay, you start with 4. Okay, you can remove this 0 and then you can start with 4. Okay, as the first row. Okay, alright, okay class? So, from the frequency here, from the frequency distribution table, first you need to know what? The class interval, right? So, the class interval, okay? You need to find the class interval, how many interval we should have in our table. The second one is class frequency. Okay, the class interval and class frequency. So from the class interval, we can derive the class boundary. For the lower class boundary, it's always on the left. Okay, so minus 0.5. Okay, and then for the upper class boundary, it's always on the right. Okay, so plus 0.5. Okay, from that, you can transform all data into the relative frequency. Okay, so we have three forms of relative frequency. The first one, we have decimal, fraction. The last one is a percentage. Okay, and then after that, we can find the value of what? Cumulative frequency, the last one. Okay, then we can finish. Why we need to find the midpoint? Why we need to find the cumulative frequency? Because we want to construct a graphical way. Okay, and then mean also will be used, midpoint also will be used for the descriptive mean and central tendency. Okay. All right, so we have histogram. Okay, so for the categorical we have the bar chart. Okay, but then for the quantitative we have the histogram. Okay, so for the histogram here, this one is a basic description about the histogram. But the most important part is, okay, so this one, is it correct, this histogram? Complete or not? Huh? This one okay or not? Okay. Complete? What's complete? Not complete, okay. What else we need to add here? The table? The label? Okay, next. The next? The title? What else? Sham? Any additional information needed? Not sure? Aisha? Okay. All right. So the most important part is for the histogram is their scales. Okay. Here. What we need for X here? The class. What we need for X here? Class boundary, right? So this one you need to refer to the class boundary. Okay? Since this one is 5, so 5, and then here is 10. Okay, this is a class boundary. But then, if you are referring to our data, okay, if you are referring to our data here, it will be this one. Okay, see the class boundary, it should be 34.5 and then here 43.5. Okay, you see from the first class boundary and the second row of class boundary, they are share their value. 43.5 and then here 43.5. So that is why when we construct a histogram, they must have here 43.5 share the same line. That is why the bar here is a close. Okay, and then you see here is for 52.5. It should be 52.5. Okay, so always the gap is a close to each other. Okay. This one okay, histogram? Any question related to histogram? No, eh? Okay. Why? Why in the bar chart we don't have the bar chart is the gap between the chart is we have a gap, right? Because of what? Because we don't have the class boundary. And plus, for the bar chart here, it's supposed to be like this, right? No gap. Because why? No class boundary. Okay, non-numerical, each of the bar are different. But for this, they are share the class boundary. That is why the bar between each other is close. Okay? Alright, so frequency polygon. Okay, what is the frequency polygon? The most important thing that we need. You can write it like, sorry. What we need for the frequency polygon class? Midpoint and also frequency. Okay, so that one is a midpoint. So the midpoint is here. Every of them are midpoint here. So that is why we can construct a frequency polygon. Okay, midpoint and frequency. Okay, Adi, any question? No, okay. Alright, so for the frequency polygon, the one is frequency, the one midpoint. Okay, the one is a midpoint. Okay, so we have the cumulative frequency polygon. Okay, the words are cumulative frequency polygon, and of course the variable or the what we call the variable involved is a cumulative frequency. Okay, so this one, an ogive is a graph of a cumulative distribution. Okay, the data value are shown in the horizontal. Okay, shown on the vertical axis are cumulative frequency or cumulative relative frequency or cumulative percent frequency. Okay, alright, so the frequency of one above of each class is plotted as a point. Okay, we see here. Alright, so we see here. Okay, this one we have an upper class boundary, and then we also have the cumulative frequency for the y-axis. Okay, so you can check the ogive is like this, and always the ogive is always increasing. Why? Because it is involving the cumulative frequency. Cumulative frequency always increasing in terms of value. So that is why the ogive is like this. Okay, so we have three already. Three methods for this. Okay, three graphical way to do the quantitative. Okay, alright. Okay, and the last one. Okay, so the last one is a stem and leaf display. Alright, okay, stem and leaf display organize data into group called the stem, okay, so that the value within each group, okay, the value within each group, okay, the leaf branch out to the right on each row. Okay, for example, we have age of survey college student. So age is a qualitative or quantitative? Quantitative. Okay, so you can see all the data here are involved with the numerical one. Okay, alright, so we have day student and then we have night students. Alright, so day student is a 16, 17, 18 and so on. Okay, and then we have night student. Okay, night student also we have 18, 19 and so on. Alright, okay, so for day student we have, what we need to do first, class? What we need to do first? Yes, correct. Okay, the first step is we need to arrange them. Okay, for the day student it started with the 16, okay, but this one is already sorted. Okay, if we get the data like this, let's say we got the data like this, we need to sort in the ascending order. This one. If we get this data like this, so we need to sort them into the ascending order. Okay, and then we can proceed with our display here. Okay. All right, here. Okay. All right. So here 16, 17, and so on. Okay, they already arranged. Okay. So that one is for day student will be 1, 6. Okay. So the stamp will be 1. See the day student data. So this one is a stamp and leaf. Okay. So that one will be 16, right? So 1. 1, 6, right? So 1 is all here. Okay, and then this one is a 2. We also have, we have 3 or not? 3. We have 4. Okay, so 1, 6, 1, 7, 1, 7, 8, 8, 8. 9 and 9. Like this. Why it become like this? Because we already arranged the data. Okay? We already arranged the data into ascending order. Alright? So, number 2. 2, 5, 7. Correct or not? 0. Sorry, 0, 0, 1, 2. Okay? 0, 0, 1, 2, 5, 7. Okay, and then we have 3. 3 is 2. Sorry, 3 is 2 and 8. And then we have 4, we have 2. This one is for day student. Alright, this is involve only 2 digits. How about 3 digits? How about 3 digits? Let me give the data. One zero one, 102, 105, 108. What else? 117, 146, 152. How to arrange this one? 2 for stamp will be 10, 10, 10, 10, 11, 11, 14, 15. Okay, this one is already arranged into the ascending order. Okay, but then if you get the scattered data, so you need to arrange them first. The solution, okay? Any question? Thank you already. So tomorrow I will release the assignment. Okay, study 30%. Okay, and then I will brief you during the practical class. Okay, during the practical class. All right. So you just fill in the what we call fill in the link provided by our class rep. Okay, seats, minimum seats, maximum seats, member of each group. Okay, all right. Okay, fill up first, and then we'll see you tomorrow. Okay. All right, class, just take the attendance. Okay, you can proceed completing the tutorial 1. Okay, maybe we can discuss tomorrow. Tutorial 1.